Chapter 1, Matter and Change. Let's take a quick second to look back over at Chapter 1 as a review. First of all, let's begin with what is chemistry. Chemistry is the study of the composition, structure, and properties of matter and the changes that this matter undergoes. If you look around you, chemistry is everywhere. Chemistry is a physical science, meaning that it doesn't have anything to do with life in most cases. Direct study of life, rather. It is also known as the central science because it is central to the understanding of both physics and biology. Without chemistry, you would have neither physics nor biology. Chemistry is also central to our everyday lives. The air that you're touching is chemistry. The desk that you're sitting at is chemistry. The chair you're sitting in is chemistry. It's all chemistry. There are 6 branches of chemistry. The first and most favorite branch of chemistry, or my favorite branch of chemistry, is organic chemistry, the study of all substances containing carbon. Typically, a lot of people, you hear organic chemistry and it has this big bad name. People do not like organic chemistry. It's sometimes difficult to understand because there's a lot of stuff to learn with it. It's a lot of memory work with it. Second branch I want to talk about is biochemistry. Biochemistry is the study of the chemistry of living things, lipids, amino acids, carbohydrates, proteins, anything that has to do with a living system or a living organism, we can classify as biochemistry. And physical chemistry is the study of theories and experiments that describe the behavior of substances or the physical changes in the physical properties of things that they undergo. It's closely related to physics. You can study a lot of quantum type theory and physical chemistry, as well as a lot of thermodynamic stuff. My second, it's competing with inorganic chemistry, but analytical chemistry is another one of my favorite branches of chemistry. It's the study of the composition of substances. We analyze things to see what it's made out of, and we also can analyze things to see how much of something's in it. For example, we can analyze, if you think of a clinical laboratory scientist in a hospital, they analyze blood to see how much cholesterol you've got in it, etc. Like I said, inorganic chemistry is another one of my favorite branches, and it's the studies of substances without carbon. Back before we had the 6, and now we've got a few more than 6, but before we had the 6 branches of chemistry, we had 2. We had organic chemistry, which is the study of living things, and inorganic chemistry, which is the study of non-living things. And the last, theoretical chemistry, in which you use technology, computers, and a whole bunch of math to try to understand how things are going to behave or understand the properties of substances. When we start to classify matter, we have a couple different or several different classifications. We can consider something homogeneous or something with a uniform composition, heterogeneous, matter without a uniform composition, and we call these a substance. A substance is a pure type of matter that does not vary from sample to sample. It includes elements and compounds. Okay? So elements are the simplest kinds of matter, made only of one type of atom. An atom is the smallest unit of an element that maintains the properties of that element. If you need help identifying elements, you can look at the periodic table. Anything that's on the periodic table is considered an element. Elements cannot be broken down into simpler substances by ordinary chemical means. Examples are gold, copper, oxygen, hydrogen, nitrogen. Anything you can find on the periodic table is an element. Compound is another type of substance. It is matter composed of the atoms of 2 or more elements, but these elements are chemically bonded. These compounds can be broken down by chemical methods. We can use chemistry to kind of break them down into simpler things. When they are broken down, they have completely different properties than the original compound. For example, examples of compound include sugar, glucose, sucrose, fructose, several different types of sugar, salt, sodium chloride, magnesium chloride, water, good old H2O, and carbon dioxide, which is what we exhale when we take in oxygen. A mixture is a blend of 2 or more kinds of matter, in which each retains its own identities and properties. And a mixture can be separated. It's mixed together physically. It can also be separated physically. Variable composition is often expressed by a percent composition by mass or by volume. An example would be if you add salt water, 5% of that, what's in your glass is salt, the other 95% is water. Another common thing that has percent composition is vinegar. 5% of a vinegar solution is acetic acid, the other 95% is water. Homogeneous mixtures are also called solutions. That's synonymous. Remember, homogeneous is the same throughout. And a heterogeneous mixture is not the same throughout. Examples would include M&M's, chocolate chip cookies, gravel, soil, rocks, granite. Blood is a heterogeneous mixture. You can separate that stuff out. You can see that sometimes. Milk, salad, ocean water, etc. You are given this flowchart. Here's how you read the flowchart. You take a sample of matter and you ask yourself this first question. Can it be separated physically? If it can be, we'll talk about physical separations, but if we can physically pull it out with tweezers, if we can filter it out, if we can do all these various things, then yes, it can be separated physically, then it's considered a mixture. If it's the same throughout, if it is, it's considered a homogeneous mixture. If it's not, if you can see different things in it, like for example, if you had a mixture of rocks and sand and grass, could you pick those out? Yes. Or is it uniform? No. We could consider that heterogeneous. If it cannot be separated physically, like for example, if we take a piece of salt, we cannot separate it physically from each other. We cannot separate the sodium and the chloride from each other. It is considered a pure substance. Can it be chemically decomposed? Can we use chemistry to break it down into simpler things? If we can, it's considered a compound. If not, and it's found on the periodic table, then it is an element. So let's use that flowchart to classify these things. You've got copper wire. Well, copper is found on the periodic table, so this must be an element. Aluminum foil. Aluminum is found on the periodic table, so this must be an element. Table salt, NaCl, is considered a compound because it's two atoms chemically bonded together. Granite. Granite is a rock, and you can see the different things. It's a mixture of several different minerals. If you look, you can pull these different minerals out, and I forget which substances make up the different parts of the granite. So this would be considered a heterogeneous mixture. Apple juice is the same throughout. It's uniform, so we would consider it a homogeneous mixture or a solution. Remember, homogeneous and solution are synonymous. Let's classify these. Take the time to classify these: magnesium, pizza, calcium chloride, orange juice, and club soda. Magnesium we can find on the periodic table, so that's an element. Pizza, we can physically pull that stuff apart, so it's considered a heterogeneous mixture. Calcium chloride, CaCl2, is a compound that is chemically bonded together. Orange juice is a heterogeneous mixture. There's always pulp in the bottom of the orange juice glass, no matter if you have pulp free or not. And club soda is considered, I can see that either way, a homogeneous mixture or a heterogeneous mixture. If you can see the CO2 bubbles in it, then it is considered a heterogeneous mixture. Now let's look at classifying at the molecular level. Remember, we cannot see things at the molecular level, so we have to have models, or we have to develop models in order for us to see. If you look at this model, you see that we have little dots probably representing atoms because they're all the same. So we would probably consider this an element. If you look at this next model, we have different sized dots, different colored dots, but they are connected to each other, so it kind of looks like they're chemically bonded together. So we could probably consider this a compound. Now, we've got all different colored dots, and they do not seem to be connected to each other. So this is either going to be a heterogeneous mixture or a homogeneous mixture. Now, looking at it at this level, we really don't know. We can't tell. Because, remember, it's just a model, so we can classify this as an overall mixture. Can't tell if it's homogeneous or heterogeneous.